Hi there, I'm Jon Hammant, and it's an absolute pleasure to be here today in front of you. And today I'm going to talk, I know Zena was saying the word serendipity, which is one of the words I really like when we think about things like this. It's really interesting when we think of the pace of technological innovation, how much of it has been determined by these serendipitous discoveries that have occurred over the years, and how much of it, as we could say in a more simple way, is just pure luck. So when you think back to your morning, this morning when you're first eating your breakfast and you may be going through you're spooning things into your mouth or cutting things up. All of that is as a result of pure luck that you're not tasting metal on every single spoon that you go through. If we think back to 1913, a British engineer worked through looking for additional ways to have anti-corrosion coatings for metal. Cool, thank you. He went through for many years, going through, trying to understand effectively how to make a better alloy going through. As he took these, he discarded them, put them in a pile, went through, and eventually went to scrape these up. And you can see as he goes through and looks into these, he discovered that one of them was still bright silvery colored. When he looked at it and tested it, that becomes the basis of stainless steel, something which is absolutely key to our life today. And if we think of other discoveries that have occurred, so much of these have been a result of this serendipitous luck. If we think back to penicillin, for example, so people may know the story of this. Effectively, it is just the result of a bacteria being caught, mold being caught on a petri dish, that it discovered that Alexander Fleming realized started to remove the bacteria around it. Pure luck, and that pure luck has saved hundreds of millions of lives. If we look even further forward, this happens again and again through the process of scientific discovery. So if we see on Easter Island, for example, so people take the ability to have transplants as something that we take for granted. So much of that is a result of a soil sample that was discovered on Easter Island in 1972, which has now been turned into a drug called rapamycin. So rapamycin is key as an immunosuppressant that everyone uses. And all of this, I find it almost mind-blowing that without that discovery, the soil sample, the testing that comes through, it wouldn't be possible today. In the same way, looking at rapamycin itself, there's huge interesting capabilities that it may have around the ability to stop cancer and the ability for large-scale life extension. It's interesting to me that for the first time, we're starting to be able to control this process of luck, this process of discovery. When we think of really what is luck? Luck is the chance of something happening by the amount of times that we do it. And before that, this has been dictated by the amount of time it takes the physical world to move forward, how many times we can try something. And that limit, that cadence, has always been dictated by our ability to make things, to build things, to put things forward. Since the moves in technology that have happened, so we all know about the exponential scaling that's been occurring. So people will have heard around Moore's law. Most people will be familiar with that. For me, there's a far more interesting law that underlies Moore's law, which is called Wright's law. So Wright's law was discovered, we should say, by an airplane fuselage engineer in the 1930s. He worked out that the more airplanes that we created, the cheaper it became to make them, which is a really interesting discovery, and the same one which has driven the advances in technology that have come through. This concept of learning by doing. The more we do something, the more we learn from it. The more we learn, the better we get. And it comes down to this ability for us to cycle through. The more we do something, the more we understand it. And all of this is being revolutionized in the way that we bring technology forward today. If we think of how we design things, so the Sydney Opera House, for example, is one of the most beautiful buildings that exists. It's one of the early uses of CAD software. When we look at the initial architect went through, he sketched it, he tried to understand how to build it, and realistically it was a moderately unbuildable building. It only took the ability to iterate it in a technological way, so taking on a computer, being able to go through and increase that cadence of design, increase that ability to do it. And this is increasing in everything else that we see. So for example, with 3D printing, we take that step even one further. So we go from a situation where we can take something, we can simulate it, we can print it out. If we look at some of the advances that are happening at the moment in rocket production, in housing, all of this is about that closed feedback loop. How do we increase the progress of technology? The more that we can do that, the more that we can speed things up, the better we go. Drug discovery is one of the places that we'll see this first. And one of the interesting things I find about chemistry, for me, I always liked maths, I liked physics, I liked science. I never really understood chemistry. I didn't really understand the complexity that goes into it. For me, chemistry felt like it was almost a solved problem. I looked at the periodic table as a child and I thought, this is something that we understand really well. What amazes me more and more is actually the lack of understanding that we really have in the processes that run underneath that. So if we take penicillin, for example, so penicillin's a relatively simplistic molecule. So it comes into around 41 atoms, I have to read this bit, 41 atoms, 176 electrons, which gives you around 285 quantum objects in total. Out of that, if we want to simulate a system around that, when we simulate quantum systems, so if we want to simulate one quantum object, we need 1 bit. If we want to simulate 2 quantum objects, we need 2 to the power of 2 bits. If we want 2 to the power of 3, 2 to the power of 4, and so on and so forth. Which, as you can imagine, gives this huge exponential scaling that's required to simulate even relatively basic compounds. One of the things that I think is genuinely going to happen in the near future is the ability to use quantum computing to understand and simulate quantum states in a way that is far beyond what we can do at the moment. If we look at penicillin, for example, for us to simulate a singular penicillin molecule, at the moment we'd need 2 to the power of 285 bits, which for the folks, a lot of folk in the room will realize is a huge, huge number. That's the same if we took every grain of sand on this planet, we converted each one of those into its own unique Earth, and then we had another grains of sand for each of them. It is an astonishingly large number. When we move into the world of quantum computing, how many bits do we need to simulate? We need 285 bits. If we think of all of the changes, all of the moves that have happened in society so far, all of these being around having luck, about discoveries, about our ability to effectively try things multiple times, over and over, simulate, take the feedback loop. Much in the same way that it was a sheer luck discovery of perseverance that came up with stainless steel, when we look forward, this won't be it. We can, the first time, create our own luck. And I think that's one of the amazing things. We've gone through multiple industrial revolutions. When we look at our ability to effectively use power as a fulcrum to move forward, whether that's either steam power, or that's fossil fuels, or that's nuclear. For me, we're coming into the 4th industrial revolution, and the thing that we're going to be able to harness is luck. It's our ability to try things multiple times and iterate to an outcome that previously we would never have been able to get to. And there's huge implications in the near term for this. So some people may know around the Haber-Bosch process. The Haber-Bosch process is something that without us, we really wouldn't be able to sustain the amount of humans that live on this planet. Every single one of you, so for people that don't know, the Haber-Bosch process effectively is a way of fixating nitrogen that goes into fertilizer, a key component for every single person here, for every living thing. It came about at a point now where 50% of your body is as a result of nitrogen that's been fixated via this process. That's something that accounts for about 1% of all energy use on the planet and about 1.5% of greenhouse emissions. And we know it isn't needed. We see legumes do it. We see multiple different things effectively doing this process naturally. Why can't we simulate it? Why can't we work out? Well, it's the complexity that comes into the quantum systems underneath it. The more that we're able to harness this ability to exponentially scale what we want to do, to create our own luck, the more that we can start to change the world. Now, for me, I think the future is an extremely, extremely interesting thing. The more that we can start to take that iterative closed-loop feedback, the more we can speed up the cadence of science. If we think at the moment, the average time to go from a scientific paper to peer review to acceptance in the world of science is around 3 years at the moment. And that doesn't even include the beginning of it, the funding cycles, the work, the research. Imagine in yourself if we could just change that slightly. So if we could change that pace of discovery by a small percentage, by going to a point that instead of taking 3 years to get from one stage to peer review to acceptance, we move that down to 2.5. We move that down by 10%. We move that down by 20%. We move that 30%. One of the beautiful things that people seem to not always understand is this law of accelerating returns. The more that we can build on top of ever-increasing things, the further we go. So I'm really excited about the future. I think we are coming into this 4th industrial revolution that will be powered by luck, that will be powered by our ability to harness scale in a way that we've never had before. So to all of you, what should you do? So think in the future, If you had the ability to try something millions, hundreds of millions, almost infinite amounts of time until you got to that right answer, until you found the thing that you were looking for, until you found that bacteria that was buried underneath the head on Easter Island, what could you do with it? What are the possibilities? And that's the future that hopefully we'll all get to live through in the near term. Thank you.